Welcome back to CodeMate. You have seen or used many AI models like GPT, Claude, Gemini. Every model has a user interface where we give input or questions and the AI answers us. Today we will build the exact AI chat box using Python and free Gemini API Key. With this we need a Python IDE, which you can get from Play Store. Before we start, you should understand why we're using an API key. We use the Gemini API key to authenticate our requests to Gemini. You can think of it like an ID card you use to enter college. The ID card tells the college who you are, and similarly, the API key identifies and authorizes our application when it sends a request to Gemini. Our program sends a question to the Gemini API through its URL along with the API key. Gemini's server processes that request and sends the response back to our program. You all get to know what I'm saying when we actually work on it in our project. So first, let's get the API key. For this project, I'm gonna use a Gemini API key. It is free and easy to get. So open browser, type Gemini API key, scroll down and click on API key sign-in link or the link given in the description below. After opening, it will show interface like this. I already have generated some key. Click on Create API Key. Click on Create Project. Write name for your key. I will name it my project. Then finally click on Create Key. The key is generated. And below you can see curl quick start. I will show you later in this video why this curl is important. Now copy the API key. Go to your Python IDE. If you are using any code editor on computer like Versus Code, you should set up Python and create a new folder for the project. So here inside the code editor, we will create JSON file, type API_key as key and paste your copied API key here as value. Why use this key value format? Because JSON is structured data. JSON objects naturally represent named values. API_key is the name or key and the actual API key is the value. Later, when Python loads this JSON object, it becomes a Python dictionary. There's a reason I'm creating a separate JSON file instead of writing the API key directly into the Python source code. This file is acting like a small configuration file. It keeps the secret separate from the main Python logic. That makes the program easier to maintain, and it also means the Python source code can stay more reusable. The code can read the key from a file instead of having the secret hard-coded into every request. Now save this file in your internal storage by naming the file like chatbox.json. The file is saved. To check, open New File Manager. Rather keeping project files anywhere, we will create a new folder. I will name it My Project. Now move that created chatbox.json file to My Project folder. Now go back to browser where we created API key and copy thw curl quick start. Open the code editor. On new page, paste the curl, and now you can able to see the contents of it. Here it given a particular structure which we are going to use while writing the code of it. Now open new editor page. Write import JSON. Import requests. I import JSON. We need JSON because both our configuration file and our conversation history are stored as JSON. Python cannot directly treat the raw contents of a JSON file as a Python dictionary or list. The JSON module gives us the functions that convert between JSON text and Python objects. Next, I import requests. This library is responsible for making the HTTP request to Google's API. Our Python program needs some way to communicate with a server over the internet. Requests gives us a clean Python interface for methods such as post. Then create a variable file. Here I'm opening my chatbox.json file using Python's open function. Now go to the folder My Project and copy the path of the JSON file and paste inside open function. I'm storing the file object in the variable file. The R means read mode because I only want to read the API key from this file. Now let's print it. And you can see the output, it's showing the exact path of the JSON file. Now file.read reads the actual contents of the file, and I store that text in M. Since the contents are JSON text, I use json.load's M to convert that text into a Python dictionary which I store in data. Let's print data. You can see it prints the contents of data, the key and value, which is actually the contents of our JSON file. And I store that actual API key in variable API_key, so I can use it later when sending requests to Gemini. Finally, data API_key accesses the value belonging to the key API_key. And after we are done reading it, key.close closes the file. First, I'll write u is equal to input. U. The input function gives a chatbox a way to interact with the user. It waits for us to type a message and stores that message in the u variable. I first run it once to demonstrate how it works. But if we want our chatbot to keep accepting messages, we need to put it inside a while true loop. Now we can enter multiple messages continuously. Finally, I add condition. If u is equal to exit, break. This checks whether the user typed exit. If they did, break stops the loop and closes our chat session. Now I'm creating history is equal to. The empty square brackets create an empty Python list. I'm using this list to store our conversation history. Now I'm creating a function called add_message. Here I'm passing three parameters: history, role, and text. History is the conversation list where we'll store our messages. Role tells the API who sent the message, such as the user or the model, and text is the actual message content. Now, notice the structure I'm showing here from the Gemini documentation. This is the format the API expects for conversation content. We have contents, then paths, and inside paths we have text. So instead of manually writing this structure every time we send a message, I'm creating add_message to build it for us. That's why inside history.append, I'm creating this structure. Role, paths, text. The values of role and text will change depending on the message, while the overall structure stays the same. So whenever we call this function, it creates a message in exactly the format required by the Gemini API and adds it to our history list. Here I've created the add_message function outside the loop, but I'm going to call it from inside the loop. Let me demonstrate why. If I call add_message only once outside the loop, it will add only one message to our history. But our chatbot needs to remember every message in the conversation. That's why the function call belongs inside the while true loop. Every time the loop runs and the user sends a new message, add_message runs again and adds that message to our history. So the function can be called repeatedly for as long as our chatbot is running. Now you will ask why I have not defined the function inside the loop. We don't want to define the function inside while true, because that would recreate the function every time the loop repeats. The function's job doesn't change, only the data we pass into it changes. So the rule here is simple. Define the function once outside the loop and call it repeatedly inside the loop. This way, our function is created once, while our conversation can continue growing with every message. Now let's create a function called get_Gemini_response. We only need history as the parameter because this function's job is to send our entire conversation history to Gemini. First, we create headers. Headers contain extra information about our API request. Here, X-goog-api-key tells Gemini which API key we're using, so we give it our API_key variable that we created earlier. And content type, application JSON tells the server that the data we're sending is in JSON format. Next, we create data. This is the actual information we're sending to Gemini. The Gemini API expects the conversation inside contents. So we put our history there. Now we need to actually send this data to Gemini. Requests is the Python library we use for HTTP requests, and post sends data to a server. So response stores whatever Gemini sends back. The URL tells requests where to send the request. I'm copying this URL directly from the Gemini documentation. JSON is equal to data sends our conversation data. And headers is equal to headers sends the API key and content type along with the request. Finally, response.json converts Gemini's JSON response into Python data that we can work with. So we store it in reply, and we call get_Gemini_response history inside our loop because we want Gemini to respond to every message, not just once. Each time the loop runs, our updated history is sent to Gemini. Before extracting the answer, let's check the response status using response.status_code. I made a few syntax errors here. Sorry about that. Let me fix them. Done. Let's run the code. You can see some codes showing up here. These numbers are HTTP status codes returned by the server. 400 means the request was invalid, 503 means the server is temporarily unavailable, and 200 means the request was successful. So here, our API is working when we get to 100. Let's first print the complete response from Gemini so we can understand its structure. As you can see, Gemini gives us much more than just the answer. We have things like candidates, content, paths, and finally the actual text. But we only want Gemini's text, so we need to navigate through this structure and extract it. I'm using Python's indexing to navigate through this response. First, candidates takes us to the candidates list. 0 selects the first candidate. Then content takes us to its content. Paths takes us to the response paths, and another 0 selects the first part. Finally, text gives us the actual answer from Gemini. We store that answer in extract. Now we use return extract. Return sends this extracted Gemini response back to wherever this function was called. Now I call our function and store whatever it returns inside the answer variable. We do this so we can use Gemini's response later in our program. Now we simply print answer with the name Ultron, so our output looks like an actual conversation. We already added the user's message to history. Now we also need to add Gemini's response. So we call the same add_message function again, but this time the role is model and the text is answer. If we don't add Gemini's response to history, our history will contain only the user's messages. On the next question, Gemini won't receive its previous answers as part of the conversation. So with this one function, we're storing both sides of the conversation, the user and the model, inside the same history. You can understand it visually like this. User message, add_message, history, Gemini API, Gemini response, extract the text, print the answer, add Gemini's answer to history. History now contains both sides. The order of these function calls is important because each step depends on the previous one. First, we call add_message, history, user, because we need to add the user's question to our conversation history. Then we call get_Gemini_response, history. Now Gemini receives the updated history, including the user's latest message, and generates a response. Finally, we call add_message, history, model, answer to add Gemini's response back into the same history. So the flow is simply: now run the program, input hi, and here you can see Gemini response. Hello, how can I help you? Let's tell Gemini I am Tony and ask who am I. You can see it saying you are Tony. Now exit the chat box and rerun the program. Let's ask again who am I? See, Now it isn't able to tell my name. Why does that happen? It becomes we are providing it empty history every time we run the program freshly. Currently, it is not storing whatever the conversation happened between user and model previously. To do so, we have to store the history in our device storage. For that, open New Code Editor window. Create a new file by opening internal storage. Get back in the project folder My Project. Now here create an empty file, name it ultronhistory.json. Save it. Open the file manager, go to the My Project folder. You can see the file, go to File Info and copy the path. Now come again in the code editor. Now our chatbot can remember the conversation during the current run. But I also wanted to remember the conversation even after I close the program. So I created a file called ultron_history.json, similar to the chatbox.json file we created earlier. Here I'm creating a variable called history_file and storing the path of our ultron_history.json file in it. This simply tells our program where our conversation history file is located. Now I'll import the OS module. OS is a built-in Python module that allows us to interact with the operating system. Here we're going to use it to check whether our history file actually exists or not. Now I'll write if os.path.exists history_file. This checks whether the file stored in history_file actually exists. If it exists, we'll open it and load our previous conversation. Here I'm using another way to open a file. With open history_file r as db. We've used open before, but this time I'm using with, because Python will automatically close the file after we are finished with it. R means read mode, and db is simply the variable representing this open file. I could call it anything, but I'm calling it db here. Now we have history is equal to json.load db. json.load reads the JSON data from our file and converts it into Python data. Then we store that data inside our history variable. So basically, we're taking our previously saved conversation from the file and loading it back into our program. And if there is no previous usable history, we need a starting point. So we use history is equal to. This creates an empty list, meaning our chatbot starts with an empty conversation history. Now we need to save the conversation back into this file. So inside our loop, I'm opening the same file using with open history_file w as db. This time w means write mode. Then we use json.dump history db. json.dump takes our Python history data and writes it into the JSON file. So history is the data we want to save, and db is the file where we're saving it. Notice that we're reading the history file before the loop, but we're writing to it inside the loop. That's because we only need to load our old conversation once when the program starts. But every time the user has a new conversation, we want to save the updated history. Now let's run the code. Here we got a JSONDecodeError. The reason is simple. Our history file exists, but it's empty or doesn't contain valid JSON. So when json.load tries to read it, Python doesn't find valid JSON data and throws this error. For situations like this, we need better error handling. So I'll use try and except. I'm putting history is equal to json.load db inside the try block because this is the operation that can produce the JSON decoding error. Then I write except json.JSONDecodeError. This specifically catches the error Python raises when the JSON data is invalid. And inside it, I write history is equal to. Because if the saved history is invalid, we'll simply start with an empty conversation instead of crashing the entire program. Now let's run the program again. Now we got another error, 429. This is an HTTP status code that generally means we've hit a request limit or quota. So instead of allowing these errors to appear without explanation, let's build a proper error handling system that tells us what actually went wrong. First, instead of directly printing response.status_code, I'll store it inside a variable. Code is equal to response.status_code. Response.status_code gives us the HTTP status code returned by the Gemini API. Storing it in code makes it easier to check different errors using if and elif. Now I'll check. If code is equal to 200. 200 means the request was successful. So we process Gemini's response normally. Then elif code is equal to 429. 429 means we've hit a request or usage limit. So I'll print limit exhausted. And for anything else, I'll print API error. This way, instead of just seeing a mysterious number, our program tells us what happened. Now let's run the program, type hi. We can see limit exhausted is printed, but none also appears because our function doesn't return a Gemini response when we hit the 429 limit. Python therefore returns none by default, and that none gets stored in answer and printed to avoid it. After printing limit exhausted, I'm adding return none. None means this function doesn't have a valid Gemini answer to return. So we are explicitly telling the rest of our program there is no answer because the API request failed. Now let's look at the place where we call our Gemini function. We have answer is equal to get_Gemini_response history. Since our function can now return none, we need to handle that. So I'll write if answer is none. Continue. This means if Gemini didn't give us a valid answer, skip the rest of this loop iteration and start the next one. Otherwise, print Ultron answer. So now none won't be printed as if it were an actual answer. Now let's run the program. As you can see, when the limit is exhausted, our program doesn't print none anymore. And when the API works normally, our model responds perfectly. But there's another problem. What happens if the internet connection fails completely? In that situation, the requests.post call itself can fail. So let's handle network errors as well. I'm going to put the requests.post operation inside a try block. I'm doing this specifically around the API request because this is the part of our program that communicates with the internet. If the network is unavailable, the server can't be reached, or the connection fails, this request can raise a network-related exception. We want to catch that exception instead of allowing our entire chatbot to crash. Now I'll add accept requests.exceptions.requestException as E. Let's understand this quickly. Requests is the Python library we're using to communicate with the API. Exceptions contains the errors that the library can raise. RequestException is the general exception class for request-related problems, such as connection or network errors. As E stores the actual error inside a variable called E, so we can see what went wrong. Then I write print network error. This gives the user a clear message that the problem is with the network rather than the Gemini API response. Then print E. This prints the actual error details stored inside E, which helps us understand the specific problem. And finally, return none. Again, we're telling the calling code that the function couldn't produce a Gemini answer. Our loop already knows how to handle none, so the program doesn't crash or print an invalid answer. We now have proper handling for different situations. 200, Gemini responded successfully. 429, our API limit has been exhausted. Other status codes, we report an API error. And if the request itself fails because of a network problem, our request exception handler catches it. Now let's run our program. I'll say, hi, and as you can see, Gemini responds. Now I'll tell it, my name is Tony. I'll exit the program, run it again, and ask, what is my name? And there we go. It remembers my name as Tony. This means our chatbot can now remember conversations even after we close and restart the program. The reason this works is because we're saving our conversation history to a file on our device. And you can see that our conversations are being stored in JSON format. And with that, we've completed the backend of our chatbot. In the next video, we'll take our chatbot one step further by giving it a voice. After that, we'll build the front end and eventually turn everything we've built into a complete application that can run directly on your device.